Welcome. It is Monday, April the 6th, and today we're going to be talking about the haloform reaction. So we're going to learn about the haloform reaction. Um, we also, tomorrow, we'll learn about the Robinson annulation. So that'll be tomorrow's. Okay, so we'll do that reaction. And then, so that's Tuesday. Wednesday, you have your Quizam 4. This is important. Quizam 4. You should have the wrapper completed, and that should be turned in to me by Wednesday. So that is on your Canvas module, and it's where it's always at. It's at that first module, okay? And you know that's worth 5 POGIL points. You do have some online POGIL from Thursday's discussion. And then you're also going to have some for the Haloform and Robinson annulation. You can submit all those online POGILs are going to be just worth 5 out of 5 points. So if you could just do one file. So for this chapter 22, you should have the 3 POGILs from your book, 23A, B, and C, and then we're just going to do one of these online POGILs. So, and that's, so that's 15 and that's 5. So you have about 20 POGIL points for this chapter total. Okay, like I said, and you can send that, I would send that to me sometime Wednesday or Thursday. You could actually, I would actually do it Tuesday night so I can give you feedback maybe. Let's talk about Quizam 4 a little bit. Okay, Quizam 4 is going to be 10 multiple choice questions, and these are going to be worth 30 points, and that's going to be available to you on Sapling. So you've been doing quizzes. If you haven't done your quizzes 8 and 9 on Sapling, then you might be a little bit behind. Not only are you getting zeros, but it also puts you at a disadvantage when you have to take all your exams on Sapling. Okay, so putting your head in the sand is not going to avoid that. And that's going to be Wednesday. And there'll be 10 multiple choice questions for 30 points. I'm also going to post on Wednesday on the Canvas module your open response. Okay, so open response, that's going to be worth 20 points. And you will print that, you will work that, and you will send that to me by email. And I will grade that and give that back to you by email. Okay, and those totals combined will make up your 50 points for your Quizam 4. And then the next assignments we'll end up having about 11 quizzes. Okay, so if you do have a 0, 1 quiz will get replaced. So if you're in a bad situation now, do not miss any more. I'm managing a lot of students, a lot of assignments, so the opportunities we have in the face-to-face classes aren't going to work for the online. Online answers come out after 5 o'clock, so I give you literally 8 hours on Wednesday to get those assessments. Okay, so that allows you to figure out your IT issues. This is organic too, so there has to be some level of integrity. So I am going to give an extra quiz, but you really got to be on top of your game. You can't mess up on Wednesdays, okay? We're down to like 3 more weeks. So I want to see everybody do really well and do their best in here. All right, so let's talk about today's reaction. And hopefully you'll get a reaction sheet, but this is called the haloform reaction. And what does it do? So we know that the alpha carbon has alpha hydrogens that are acidic. Okay, so in base, we're just going to do these reactions in base, like sodium hydroxide. It's your typical base here. You can form the enolate, right? And this is the mechanism. In the haloform reaction, your electrophile then is it's some kind of halogen. So it can be Cl2, Br2, or iodide 2. Okay, and so what happens here? Let's look at a reaction. You have like a ketone, and you react it with chlorine and sodium hydroxide. Now you always find your alpha carbon. You write in your alpha halogens, and then the sodium hydroxide will deprotonate to make your enolate. Okay, that's step one. Form enolate. And then your chlorine, your halogens, can be polarized to make one positive and the other one negative. And so then these electrons will go after the positive. This is your electrophile. This is your nucleophile. And then those electrons leave, and you get the chlorine added to your alpha carbon. Okay, so you know this mechanism. Now, this is base promoted rather than base catalyzed. So what does that mean? Catalyst means you can put probably 10% equivalence. Okay, so for every 1 mole of ketone, you can do 0.01 mole of base. But that's if it's catalyzed. If it's base promoted, for every 1 equivalent, so for every 1 mole of ketone, you have to have 1 equivalent, 1 mole equimolar of base. Okay? So now, the haloform is really about the methyl. You see it really in methyl ketones. Okay? So we're going to show you what a methyl ketone is. That's your substrate. So if I were you and I was filling out my reaction sheet for the haloform reaction, I would say my starting material are I would say that they are methyl ketones. There's my starting material. And my reagents are sodium hydroxide and a halogen. And then your product is going to be a carboxylic acid. So it's going to be a carboxylic acid plus a haloform. Now what's a haloform? Okay, well CHCl3 is called chloroform. CHBr3 is bromoform. What do you think CHI3 is? Iodoform. Okay, so that's the haloforms. Now, if you read your water bill, if you live in eastern Kentucky, your water bill produces these haloforms. And they say that they're toxic. And so read your water bill next time, okay? And they have certain levels and they're toxic and it's in your water. We had a nice chemistry seminar that talked about these haloforms in our water, and I wasn't even aware. And what's happening is when you have organic matter that have a methyl ketone, so here's a ketone and here's a methyl, so I'll just write CH3, okay? So that's a methyl ketone. And you treat it with disinfectants like bleach, Cl, and base, you're going to get, so this is 2-pentanone, and this is your product. Butanoic acid plus CHCl3, chloroform. And that's all your 5 carbons. So let's look at that mechanism. And this is the mechanism I would get in your notes. Okay, so sodium hydroxide, and we're going to use bromine. Okay, first thing, find your alpha carbon, write in your hydrogens, draw your enolate. There's my monkey face. And then put in your Br, delta positive, delta minus. Those electrons go there. And now you have Br there, and that carbon. Now this is the key. This product, the alpha hydrogen, is more acidic than the starting material, the methyl ketone. And why would that be? Because the bromine is electron withdrawing group. Remember, your halogens are electron withdrawing. Okay, so this makes these other two hydrogens more acidic. So you still got sodium hydroxide. All right, so now we're going to form an enolate again. This time we have Br there, and we have our enolate. Okay, and we still have Br. And so those electrons will go here, and we'll make Br blue here. Br, Br, and we still have a hydrogen. We still have one alpha hydrogen. This is even more acidic than the previous one, this hydrogen. So we still have base. So we still have sodium hydroxide. And let's take away all right. There's your enolate, and you still have bromine. And now you have 3 bromines. Okay? Now, this here is an excellent leading group. And you have a strong nucleophile. Okay? So, and you have your electrophile here, the delta positive on that carbon. So here, those electrons will go here. You did this the first week of school in Organic 2. You made your tetrahedral intermediate. So we make a tetrahedral intermediate. I expect you to be able to write this mechanism. And there's your OH. OH. Okay, so that's your tetrahedral intermediate. We'll write that down. Tetrahedral intermediate. And then what happens? You want to reform the carbonyl, and the CBr3 is going to be your leading group. So let's reform our carbonyl. Those electrons will go here, and then these electrons leave. So what does that look like? OH, then you have C, Br, 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 okay? And then this will take away that hydrogen, and you will form the chloroform. And this is the bromoform, right? To be exact. There's your hydrogen. And then what you do is you put it in the separatory funnel, and then you would get this protonated. Okay, so and that gives you your carboxylic acid. And that is the mechanism of the haloform reaction. So it is a ketone base promoted alpha carbon is completely halogenated. Methyl coat, I'll just write the little summary here. So the ketone, the methyl ketone, it's base promoted. Base promoted alpha carbon atom is completely halogenated. Methyl ketones have 3 alpha protons. They undergo halogenation to give trihalogenated ketones. And then the base will attack the trihalogenated ketone, which is your leaving group, to form a carboxylic acid. Okay, so just to reiterate this, we'll do it with an R group, an ER. Here's your methyl ketone, okay? You would basically have this in base, and you would have excess, and you would have excess, let's say chlorine. This would form, if you didn't have to draw the reaction mechanism, that's the product of that. And then this would undergo the sodium hydroxide. This could come here, this would go up, and then that would leave, and you would form CHCl3, and then this would get protonated to form your carboxylic acid and your haloform. Like I said, look at your water bill and you would see that. I don't think I have any questions for you to work, so I'm going to add one. Okay, so your POGL exercise that you can add here. So let's draw the product and reaction mechanism for the following reaction. And let's do excess sodium hydroxide and excess iodide. Okay, so draw the product for this reaction and the reaction mechanism. Also, I want to say also on your Quizam 4 wrapper, we did not go over that there's a reaction, last reaction on the last page. It's a fill in a box. We did not go over this, and we're not going to. It's in your book. You can look in your textbook if you want to look at it. You can also look at your slides, but you're not responsible for that. One reaction that I didn't have on that Quizam wrapper was the haloform reaction. So you can just replace that on your Quizam wrapper with this problem here, okay? And that will be what you can expect for your reaction exam wrapper on Wednesday.